Hey guys, I'm starting a series talking about functions and their transformations, and on this first note, I'm going to be showing you the drafts of basic functions. Let's go. Hey guys, and welcome back. Franck here, and if you have not subscribed yet to my channel, go ahead and do so right now. Today I'm going to show you how to draft basic functions. And just like before, what we're going to do here is get a bunch of x values and their corresponding y values, plug them into the xy plane so that we can connect them and get our draft. So we're going to look at 6 different drafts, the y equals x. We're going to look at y equals absolute value of x, then y equals x squared, and then its inverse y equals square root of x. And then we're going to look at y equals x cubed, and then its inverse y equals the cube root of x. And so to do that, I'm going to look at values for x around the origin. So I'm going to have -2, -1, 0, 1, and 2 for my x value. And so starting with the first function, y equals x, I'm going to have for y values -2, -1, 0, 1, and 2. And so with these 5 points, you can go ahead and plug them into your xy plane and you would get your draft. Now, one thing that I need to point out here is that for those basic functions, usually you would need at least 3 points in order to have the general shape of the draft. But if you're not sure what the draft looks like, it would be in your best interest to look at more than 3 points. So for instance, 5 points like here. So for this particular one here, if I plug those points here, I'm going to have -2 and -2 here, then -1 and -1. Then I'm going to have 0, 0, 1, 1, and 2, 2. Now by connecting them all, you have your line y equals x and you're done. Okay, so let's move to the next one. Next one we're going to have is y equals to the absolute value of x. So it's going to be like the previous one, but in this case, we're going to use absolute value for x, which means that we don't want any negative answer for the output. So for the outputs here, we're going to have the first one here being 2, because absolute value of -2 is just 2. The next one here is going to give us 1. Then you're going to have 0, then 1, then 2. And so with this, you can plug them into our plane again. We're going to have the point -2 and 2, -1 and 1, 0, 0, 1, 1, and -2 and 2. And so with these 5 points, you can see that your draft will look like this. The next draft I'm going to have here is the draft for the function y equals x squared. So I'm going to have for the x value here, -2 squared is going to be 4, and then I'm going to have 1, because that's -1 squared, then 0, then 1, then 4. And so with those points, I can plug them in again, and I'm going to have the point -2, 4 here, the point -1, 1, and then the point 0, 0, the point 1, 1, and the point 2, -4. And then if I connect them together, you can see here that you have your nice parabola. So these are 3 basic drafts that we have already. The next one I have here is the inverse, in quotation mark, of x squared, which is the square root of x. And so for this particular one, the function's domain is only for all the x that are positive or 0. So no negative x in this case. And also, since I want to have perfect numbers, I'm just going to have to consider the point 0, 1, and 4 here. So that 4 will give me a perfect root, and that will be 2. And so my y value here is going to be the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So I'm going to ignore the negative side here because those are not part of the domain. And so with these 3 points, I can plug them into my draft, and I'm going to have 0, 0 here, 1 and 1 here, and 4, 2 here. And then connecting all those points would give me my draft for the function y equals the square root of x. Next, we're going to move into the y equals x cubed draft. Again, I have my 5 locations here, -2, -1, 0, 1, and 2. And for the y coordinate, I'm going to have -2 here raised to the power of 3. That's going to give me -8. Then I'm going to have -1 raised to the power of 3. That would give me -1. Then I'm going to get 0, then 1, then 2 to the power of 3 would give me 8. And so with that, I'm just going to have to go and plug them into my draft here so you can see what the draft looks like. And so -2, -8 is going to be down here. And then -1, -1 is here, then 0, 0, then 1, 1, then 2, and 8. And so with this, I can just connect these points, and you can see here now you have the shape of an X-cube graph, and you're done. The last basic graph I want to talk about today is going to be the inverse of the X-cube graph, which is going to be the cubic root graph. And so I'm going to have, again, 5 points here, but since I want to have perfect cube root, I'm going to have my point here as the inverse of the points that I had before for the X-cube graph. So I'm going to have for the X value here, -8, -1, 0, 1, and 8. And so with that, I know that my Y value is supposed to be -2, -1, 0, 1, and 2. And plug them into my graph. It's going to give me -8 and -2, -1 and -1, 0, 0, 1, 1, and finally 8, 2. Then finally, I can connect them together, and I have my graph. And with that, we are going to be done. And so you have these 6 basic graphs that you should know by heart how to graph, because as we move on, we're going to start talking about transformation. And as we talk about transformation, you first need to know the basics, and that's what we did here today. And so next time, I'm going to introduce transformations on these basic functions. And if you like the way I break down the material, give me a thumbs up, and I will see you next time. Bye-bye.